Hey guys, this video is on about maximum depth of binary tree Leetcode 104. So you can definitely solve it using depth first search, but because this is a breadth first search series, we will be kind of looking into how we can solve this problem using breadth first search. So, the key value I want to kind of again point out is the fact that you can kind of visualize the queue as a 2D structure. Um, the visualization of a queue. This is what I mean. So you got a tree over here, right? And then, but if you look around internet, what you will find is, you got people will tell you, hey, you got to use queue if you want to do level order traversal, which is breadth first search, right? Three, process nine, process 20, and then so on, and go on level, right? And then add it to the queue as you go, and then take them out. But it is really, like I said, I think it's sometimes it's hard to visualize this queue because it's a one-dimensional queue, and then there's the state of the queue changes, so you gotta keep track of the queue per iteration, right? Because things are coming out, things are going in, so it's like you gotta redraw it and cross things out. So it really does take a brain cycle and you know and some time drawing it and understanding what's going on. So a good way is to kind of visualize this 1D queue into using a 2D structure. Um, so imagine like you have a two-dimensional grid, and but it's queue. So level, each row represents a level, and you're kind of iterating through this matrix or a grid. And it's to do that, well, we'll need to run a some kind of nested for loop, or nested, something with nested loops, right? And this really aligns with the code as well, perfectly, because the nested structure really aligns perfectly with this this two-dimensional structure. So, and really it becomes easier to kind of reason about. So if you look at the let's look at the implementation. All right, so max depth, right? So let's just write out the base case. No, root turn maybe zero. Yes. And we want to visualize this queue. Well, I wouldn't want to use. I don't like, for simplicity's sake. Let's fill out the levels. And I know it's kind of confusing right now, but as we write out the code, it will be better. So levels would be our queue structure. But if we treat it like a two-dimensional structure, even though it's a one-dimensional thing, so something like while levels um, for, I don't know, like for item uh, something, right? Like so yeah, if you can kind of see this nesting of loops really hint us, it really blends really well with the two-dimensional, like imagining it like a two-dimensional structure. And one thing really, it kind of automatically, like, I really appreciate about this particular, you know uh, this method, is that it really like allows me to think, oh, in the middle, as I'm iterating through the rows or the levels, I really can have access to the properties of the level, right? So I can kind of go like, hey, I can just kind of ask for like levels, and then kind of go like, oh, this is the level length, right? Before, and then, so literally, like, yeah, so that's what I mean, I think. So I can really access the properties for a particular level, and I can really do some other cool stuff per level, right? So in this case, I just want to add one as we go, and really find out how many levels there are, right? So like if we kind of go like count zero plus one, and then really just um and now in this within this for loop, we're kind of processing the row or the level itself. So to process that, now this is the tricky part. It's like you have to you gotta add. Well, the processing bit is, well, all you gotta do is like you gotta add the children nodes to the next level, right? So the way we do this is uh okay, let's complete this first. And we pop that out. So let's get the pop out like that, and a node, and then count. Sorry, we gotta add the children to the next rows. So the way we do that is simple. We can just left, right, and just kind of like go this, and then left, right, and that's pretty much it, really. I mean, it's nothing. Yeah, and then just return the count. So yeah, what we're doing is like we're kind of iterating through the rows, and then or the levels, and we're accessing some level properties and keeping track of how many levels there are in between um, the for loop and the while loop, and just kind of doing stuff which should run. All right, okay, let's test this one. Yes, should okay. It's all good. It's all good. So yeah, I think the main bit again is literally visualizing this structure. You know, if you visualize this as this structure, I think it's much easier to kind of reason about, and I feel like it's easier for me to kind of talk about also and look at the complexity. And as the problem gets harder and harder, I think developing this foundational building blocks to kind of tackle the harder problems is very important. So yeah, that's for this video. Thank you.